All right. Batteries. We're going to talk about those a little bit. First thing is testing on it. I use a Medtronic tester, which is a very high-end battery tester. Some things I'm going to skip. It's not important, like the date of the battery. I don't care. I only care on how that battery performs. So I'm testing it in the vehicle. It's not out on the bench. I'm connecting to top post. It's not a side post like General Motors uses, or a jump post on the firewall. This is a regular auto battery, standard lead acid. It is not an AGM. You select the battery type, and I like to use CCA, cold cranking amps. These other test messages like CA, MCA, those are actually used as a marketing ploy to make you think your battery is a healthier, stronger battery than it really is. Old industry standards using CCA. Check clamp connections. There, we got it, I think. Now we got it, English. I don't care about my clock. All right, in vehicle, top post, regular standard lead acid, CCA, and this battery rated capacity is 600 CCA. So
Where do you find that out
we're
on the
going
battery?
to test that it is on the label somewhere on the battery. They may have MCA and CCA, either one. I always want to test at CCA. Kind of covered up here, but you can see it right here in this area on the tag, and you'll see there's different ones on there on it, depending. CCA is the top one, 600. MCA is the second one, 750.
So for these EFI motors, what's an acceptable CCA?
EFIs don't take a lot to crank them. They spin easily, are unlike Optimax motors. So I would like to see 700 to 800 cold cranking amps, because you're going to have other electronics on your boat besides just your motor on it. I don't know the exact spec on an EFI, but I suspect it's somewhere around 600 minimum on it. Remember, minimum is motor only. No live wells, no bilge, no lights, no electronics. If you're on the Optimax motors, larger motors, I like to see 950 CCA on it. Mercury actually says 800 minimum, but we found on bass boats that's nowhere near enough. You're going to have grass flickering and going off. The motor's going to crank slower, which wears out the starter faster, and you're wondering why it's cranking slowly in the winter on a cold startup. What I'm more concerned with on the EFI motors is reserve capacity on it. I'd like to see at least 180 minutes of reserve capacity or 100 amp hour rating on them. Okay, we're going to continue with the test. Okay, we just recharged this battery because it was down about 30%. and now the voltage is 1298. This is a little deceiving because it just got charged. This battery has what we call a service charge. This battery fully charged should be 12.65 volts. If I ran the lights or live wells for a couple of minutes and then retested this, it would be down around 1260, 1265. So if you got a surface charge, it's going to trick you into thinking that a fully charged battery, and it may not be. That has to be removed. If you let the boat set overnight till tomorrow and rechecked it, you would find it much lower than that on it. The measured CCA on it was 670, which exceeds the spec on the battery, and that's not uncommon. A really good battery, sometimes it may exceed by 5 to 10%. Because you see, we put it rated 600, it actually measured 670, but this is a fairly new battery. Now we're going to do some other tests here called voltage drop tests. These tests are very, very important to diagnose problems.
You said a voltage drop test?
Voltage drop test. We're going to measure how much voltage drop we have, which is a direct result of resistance in connections, wire length, cable size. All those things affect voltage drop. So, first one we're going to do is we're going to go from positive terminal on the battery. Which is this one right here. And I picked a large wire going to the power point hookup. So I'm checking for voltage from positive to positive. So what do you guys think we should see? Think about that for a minute. With no load on the system, I should see 0 because I'm going positive to positive, which we do. But let's look and see what it is when we crank the motor over. That's the important thing, is when there's a load put on it, is how much drop do we have. Now, we're going to spin the motor over. What did I get wrong here? I got set for ohms, not volts. That's what I got wrong. All right, let's do that again. .626, that's just a touch over half a volt. And that's about what we normally expect to see on each side of the circuit on it. Our total voltage drop, we do not want to exceed 10% maximum on a cranking circuit. So now we're going to check the negative side. That voltage we just saw was voltage loss, but due to resistance in the circuit. Okay, we're on the ground cable of the battery, and we're going to put it on the ground cable of the starter. We're going to repeat the same test. Almost the same reading, half a volt. Add the two together, because you got half a volt each side. That's 1.2 volts or 10% of a 12-volt battery. That's acceptable and expected.
So this is indicating when you're cranking the battery, that's how much voltage drop you're getting.
That's how much loss we have.
Yeah.
That loss is because of resistance and battery terminal connections, the wire size, coming from the battery to the motor and how long that wire is. The longer the wire is or cable is, the more loss we're going to have. The smaller the diameter, the more loss we're going to have. So those are the things you have to think of to correct it. If on one side I saw 2-volt drop, and the other side was half, now I'm going to concentrate on that, everything between the points of measurements I took. All the connections. The connection here is this cable got broken strands in it somewhere. Has it got green growth growing on the inside of it, which means it's into this lifespan. So this test could be extremely important for your electronics on your boat too. You do a voltage drop test to find out how much line loss you have going to your electronics, especially if you go to start the motor later in the day and you see the screen blink or turn off. That's an indication of excessive voltage drop. Check it. And it could be too small a wiring, it could be bad connections, it could be low voltage in the battery. But those are the steps you go through to diagnose that problem. Voltage drop tests are very valuable, valid tests. Do not use an ohm meter to check for resistance in these types of circuits. On an ohm meter, you can have 0 ohms of resistance, but won't even start to crank your motor. Resistance is relative to the load being applied on it. If you have a load, resistance is going to show up at a higher amount on it. Voltage drop test is the only way to do it accurately. Ohm meter is not to be used for voltage and replacement for voltage drop test.